Um, my name is Andreas Bressler, and I'm gonna moderate the session for you guys today. And I have the pleasure to introduce Cedric Neutel to you. He is one of our YUFE for postdocs at Maastricht University. And Cedric is specialized in research on the so-called forever chemicals, like PFAS and PFOAs and their effects on our health, and particularly on cardiovascular health, so our heart and blood system. And Cedric is going to give us a small glimpse into this very detailed and yet far-reaching topic of his with this lecture today. And with this, I'm going to hand over to Cedric. Yeah, good luck and have fun, everyone.
Thank you. Thank you very much, Andreas. It's a very, very nice introduction, so I don't have to introduce myself then anymore. But indeed, it's true. I am a postdoc here. I am mainly researching always cardiovascular diseases. In the last years, I've shifted my attention towards urbanization, pollution, and how that affects our heart and our blood vessels. So let's get into it. So this is a map that I pulled from the European government, from Eurostat, which shows the degree of urbanization across Europe. Mind you, this is in 2021. Something that you already can see is that the region where we're from, so the Netherlands, Belgium, these are highly urbanized regions. As you can see, many cities, a high population density, and this is only increasing. So with higher urbanization, so more cities, bigger population density, we get some challenges. Some of these challenges are, as you can imagine, in cities, there is a lot of noise. So there is a lot of noise pollution. I think you can also appreciate that there is also a tremendous amount of light pollution due to cities in our regions. And of course, the well-known air pollution and chemical pollutions. So my goal here today is to delve just a little bit into each and every one of these topics to just scrape a little bit of surface to show you what we know about these types of pollution and cardiovascular disease. Because the World Health Organization, the WHO, one of their key missions is to improve urban health. The WHO knows this. They know that almost 50% of the population lives in highly urbanized regions, and this is only going to increase. What they also know is that in these urban regions, almost everyone is exposed to polluted air and many other pollutants. And then what I highlight is that the WHO, they acknowledge that this urbanization and all these risk factors from these pollutions, that it could lead to higher levels of what we call non-communicable diseases. So non-communicable diseases, what do we mean with that? Well, non-communicable diseases are what we call chronic diseases, like cardiovascular disease, so diseases of the heart and the blood vessels, chronic respiratory diseases, think of asthma, for example, COPD, diabetes, and cancer, of course. Now, if we look at these non-communicable diseases, we know that cardiovascular disease has always been and still is the #1 killer in the world. 33% of all deaths globally are due to cardiovascular disease. So that's a tremendous amount, followed closely, as you can see in the other graph, by cancer, of course. When it comes to cardiovascular disease, we know there are many risk factors that I'm sure you're aware of as well, like bad diet, high blood pressure, obesity. These are all big risk factors for cardiovascular disease. And lately, they've also been adding air pollution to that bunch. When you think of cardiovascular disease, most of us, we always think about the heart, which makes sense. But the most underlying cause of cardiovascular disease is almost always the blood vessels themselves. As you can see, high cholesterol, high blood pressure, these are all things that affect our blood vessels and in turn will affect our heart. So I do want to take this little moment to take a little sidestep, and that is more to look at what are blood vessels, what do they do, blood vessels, how are they important? Because a lot of people, if we look at cardiovascular disease, a lot of people just focus on the cardio, so the heart part of it, without actually negating the blood vessels. And since I am actually doing a lot of research on blood vessels, I thought I wanted to take this opportunity to just explain a little bit or scrape the surface on blood vessel function. And when we talk about blood vessels and what do blood vessels do, we often refer to this Windkessel effect. So in this figure, you can see above, for example, a fireman who is going to extinguish a fire somewhere. So they're pumping out blood. Sorry, they're pumping around water. Blood is that comes next. They're pumping out water, and then they have this kind of reservoir that allows, because of with pressurized with air, that allows that they can actually have like this nice continuous jet of water that is well spraying out that they need to extinguish fires, right? You can actually compare the cardiovascular system very much to this. You have the heart, which is a pump in essence that wants to pump blood around. And the blood vessels, they kind of act as this Windkessel because our organs, like kidneys or brains, they want, a very continuous flow of blood. And our arteries, our blood vessels make sure that this pulsatile blood flow from the heart transforms in a nice continuous blood flow in the organs. So they're tubes, you can say. So what we know is that we have normal blood vessels, normal healthy blood vessels. As I just said, they are compliant, they can stretch, they can recoil. They will eventually generate what we call a non-pulsatile pressure. Like I said, a nice little continuous blood flow, and that's important for our organs. The problem is if our blood vessels get sick, and this can be due to various amounts of reasons, most of the time they get stiff. Like a stiff garden hose, the water it jets out very quickly out of that. The same thing happens here is that if our blood vessels get stiffer, what happens is that our pulsatile flow is becoming more pulsatile, and that is going to damage our organs. So with this, I just want to say that, stiffer blood vessels, they can result in cardiovascular diseases like strokes and infarctions. And this has been proven time and time and again that individuals who have stiffer blood vessels will have an increased risk for cardiovascular disease. So when it comes to arterial stiffness, then there are many reasons. As I said before, you have genetic reasons for like genetics that can cause arterial stiffening. There is aging itself, and plenty amount of risk factors that can damage our blood vessels. And it's the second one that we're going to focus on now a little bit, because one thing that I'm investigating in my research is how the environment, our exposure to the environment, is one of these newer risk factors that could lead to arterial stiffness. So that's what I'm researching, is to understand how our environment is changing or damaging our blood vessels. With this little side tour, I want to go back to the main topic, and that is to see or show you what we know about pollution, urbanization and pollution, and how this is going to affect our cardiovascular health. Now, I do want to say that with this presentation, my goal is really to scrape the surface. I want to show you literature that I found very interesting and to give you an idea of what we know in the field. This is by no means like everything, right? That's impossible to give in a smaller lecture. But these are impressions from what I know from a literature, stuff that we are researching as well. So the first thing that I want to talk about is noise pollution. Because, in cities, there's lots of traffic, a lot of cars in cities. Sometimes there are airports or planes and railways and so on. One of the earlier studies that I could find where they actually, and this is in Switzerland, I think, they were studying how exposure to roads, railway, or aircraft noise is actually linked to arterial stiffness. They found that traffic noise is not that big of a deal. Aircraft noise, not really as well, but railway noise, it seemed, as you can see from the right-hand square, is that with more exposure to railway noise, they found that these individuals had a higher amount of arterial stiffening, so a higher risk for cardiovascular disease. And that went actually concomitantly with, in the left red square, to an increased amount of day sleepiness. So they found that those individuals were more sleepy over day, but they also had higher cardiovascular risk. An interesting thing is that these authors in their study, they mentioned that, well, presumably, it seems that there is an interaction between a stress reaction on the one hand, due to noise, which then could potentially affect how we sleep. It could disturb our resting periods, and that could eventually lead to that cardiovascular risk. So that's something to keep in mind. These were the first ones that were saying, okay, maybe noise exposure is actually a stress response. Oh. So then another very beautiful study actually looked at a summary of different studies. What they found was that they were also looking at transportation noise and how this could affect cardiovascular health. As you can see from the graph, and you should be focusing on the overall graph, is that indeed individuals who are exposed to more transportation noise or more environmental noise have a higher cardiovascular risk. And they even broke it down into different kinds of diseases such as heart failure, strokes, and heart disease in general. Overall, as again, they found that more transportation noise was linked to more cardiovascular disease. And now this is a big figure, but I think with this figure, they really encapsulate everything that noise pollution probably is. And again, they say that with noise exposure, they observed, okay, sleep disturbances. They observed, again, a disturbance in sleep, disturbance of activities, and all of that led to a stress response. And then on the figure on the right, they show this axis between the brain, the kidney, and the blood vessel is that our stress response eventually hits our kidneys. Our kidneys, due to this response, will secrete stress hormones, and these hormones will affect our blood vessels, and they will damage our blood vessels. So this is interesting. So now we know, we kind of, from more literature, we know that this exposure to noise seemingly is a stress response that can also affect our sleep pattern, and that all could accumulate to damaging of our blood vessels. And it brings me to the other type of pollution that is very much tied into this, and that is light pollution. So this is a picture from the ISS, so the International Space Station, taken by one of the astronauts from the Netherlands at night. So you can see one of the major cities, Utrecht, Amsterdam, Rotterdam. They are very illuminated. There's a lot of artificial light at night in these cities, and a big question always was that, is this light, this artificial light, at night specifically, is it affecting our health? Surprisingly, there's very little research done on this, but the research that has been performed has been showing one thing consistently, and that is that if we are exposed to more light at night, and in this study they even found like every increase in 100 nanowatts per percent per cubic centimeter actually increase the risk for cardiovascular disease. So again, there are very few studies on this, but most of them show the same thing. Like if we are exposed to more light at night, apparently this is resulting in a higher risk for cardiovascular disease. Now, this 100 nanowatts per square centimeter, what does this actually mean? Because this is a random number. So I just want to put that in perspective for you. So, for example, Las Vegas, I think we can all agree is the most illuminated city in the world. You would say that it's like 100 to 150 nanowatts per square centimeter of kind of radiance. Compare that to cities in Netherlands, like Utrecht, for example, they are generally much lower, between 20 to 40. And then, of course, you have these parks, which we call dark parks. Like in the Netherlands, we have some of them, but across the world there are as well. They have almost no radiance. So this is where you can really see the Milky Way in the night sky. So just to give you an example of what that means, because the previous study showed that every 100 nanowatts exposure is linked to cardiovascular disease. There is one thing that we do need to mention here, and that's for now, especially with these images, I'm showing you radiance from city lights at night. You do need to understand that, yes, this is a factor, but there is another factor which is probably equally important, and that's the light that's emitting from our electronic devices. So we know that, and I mean, this is pretty much talked about, like you should not be watching television right before you go to bed to sleep, or you should really refrain from using your smartphone in beds. To be fair, I'm guilty of that as well. I mean, a lot of us are. But that is because these devices, they do emit strong radiances. This can go from 10 to 300 nanowatts. It could even be more in the tens of thousands. So we should not underestimate not only the light that the city is emitting, but also the light that our devices are emitting when we're scrolling in bed or watching television at night. Because the mechanisms of artificial light at night, so ALAN, well, what we kind of expect is that that light is going to affect our synthesis of this little molecule called melatonin. And melatonin, as you might know, is very important for our sleep. So what we know and from studies is that being exposed to a lot of light decreases our melatonin production, which will affect our sleep. And so this is where it starts to tie in with noise pollution, because noise pollution was also linked with sleep disturbances, cardiovascular health, and stress. And actually, it's very similar how light exposure works. We have sleep disturbances, there is a stress response, and it can affect our risk for heart disease. Again, there is really limited amounts of evidence for this yet, so more research needs to be done. But what we know, and this is pulled from an abstract from a conference in the United States from last year, is they found that a higher exposure to this artificial light at night was linked to a stress response, and especially stress-related activity in the brain, inflamed arteries, so again, showing that that damages our blood vessels, and an overall higher risk for heart disease. So with this, again, with noise pollution and light pollution, it seems to be that these kinds of pollution are affecting our sleep patterns, our circadian rhythms, are increasing or inducing a stress response. And these things can eventually lead to damage to our blood vessels. And that itself is the underlying cause or reason most of the time for cardiovascular disease. And that brings me to two very different types of pollution, air pollution and chemical pollution. And I'll explain you why they are different. So let's start with air pollution. As we know, and this is also pulled from another very interesting paper, so like, okay, when we look at noise pollution, in essence, 20% of the population is exposed to noise pollution, which is limited compared to light pollution, which a bigger portion, like almost 80% of the population is exposed to what we call light pollution. Air pollution is almost everyone. They only don't mention 100% because we rarely want to use 100% in data, but in essence, everyone is. So air pollution really is dramatic in that scale that no one is spared. So air pollution, what is air pollution about? Or maybe you might have heard these terms, I'm sure you must have, is we have two types of air pollutants. We have gases, of course. Think about like nitrogen dioxide, carbon monoxide, like things that get released from combustion, for example, due to traffic. But on the other hand, we also have particulate matter, sometimes what we call fine dust. And particulate matter are very tiny particles that are categorized in size. So you have PM 2 to 10, and then smaller than 2, for example. So this is all small particles that are in our air, mainly due to traffic, for example, combustion cars. It could also be that it's from natural causes. Think, for example, of wildfires. If you look at, for example, in California, not so long ago, these wildfires, they really increase air pollution dramatically. But then again, we also have regions that are where there are lots of factories around, like some cities, they do have a lot of chemical plants and so on. We know that these are sources of different kind of air pollutants as well. So of course, these are all different kinds of gases, fine particles. So one of the things that we are researching for many years now is to try to understand how they link to our health. Because, for example, this is a map that I pulled from the Netherlands that shows hourly rates of particulate matter. And this is pulled from this weekend. So you can see that there is still higher amounts of particulate matter in different regions. It's very like unstable. It goes up and down over a full day. But with this, I just want to show you all of us are exposed. It's not only in the bigger cities. So we know about particulate matter, we know about gases, and this is an infographic that I pulled from the European Environment Agency, who is very much involved in monitoring this pollution and trying to understand the effects it has on our health. So PM 2.5, so these are very, very small particulate matter, very small particles that circulate in our air, is found to be a major cause of death globally. So it's not just something that is maybe bad for us. It is really shown that particulate matter is a cause of death in a lot of individuals. And then if we look specifically, what kind of mortality or what kind of diseases they induce, again, we see in their top two for particulate matter is ischemic heart disease and strokes, cardiovascular disease. Same thing goes for the gases. Nitrogen dioxide is one of the most occurring pollutants, gases in our regions and globally as well. And also there, we do see again that cardiovascular disease, stroke, is one of the top diseases that these gases induce. So clearly, there is a big correlation between air pollution and cardiovascular disease. I cannot show, of course, there's so much research going on particulate matter and gases and cardiovascular health and trying to understand how it works. There's too much to show you in a limited amount of time. But I wanted to show you this study because I think this is an interesting one. It's been published in a very big journal in our field of cardiovascular sciences. And actually, they were showing how exposure to different concentrations of PM2.5, so the biggest killer of the bunch, is actually causing cardiovascular mortality. And what is specifically interesting about this is that by the time that this study was performed, you can see in the graph the 12 microgram per cubic meter. That was the safety limit for a very long time in the US. And they said like, oh, everything below that should be fine. Higher is bad. This study found that even in those lower concentrations, there was a significant effect on cardiovascular disease. So even lower concentrations than the US threshold at that time was causing disease. And this is why it's important to keep researching this, is that because we need to get a better understanding of it so that we can actually give better information to policymakers. So like, no, listen, we really need to go much lower than that because apparently our thresholds are not working. So this was a very interesting study to read through and gives you a lot of perspective. So when it comes to mechanisms, this is very different than noise pollution and light pollution. So noise pollution, light pollution, my take on it was that a lot of it is stress-induced, sleep disturbances. It's very different for air pollution. Air pollution really directly attacks us. We breathe in these gases, these particles. Of course, the lungs are one of the first organs that they get into contact with. So you can imagine a lot of damage to the lungs. But what is interestingly or more interesting for us is that, and you can see on the left-hand side, that these particulate matter and also gases, to be fair, they induce inflammation. And inflammation eventually gets systemic. So like it's not only to our lungs. The moment they inflame our lungs, our full system is on fire, so to say. And they found that this inflammation is actually one of the leading causes of why we get heart disease, why our blood vessels get damaged. Because our blood vessels are the first ones to come in contact, besides the lung tissue, of course, with these fine dust, these fine particles and gases. And they found that they can get into the blood even. So long story short, like our gases, air pollution, which can come from different sources, cars, factories, natural causes, we breathe in these particles and eventually they will light us on fire, if I can say that, by giving a lot of rise to inflammation. So that's very different from noise pollution and light pollution. Then I want to get something that I'm more involved in as well, which is chemical pollution. The problem with chemical pollution is that it is even more widespread than air pollution. If you think that air pollution is already complex with, okay, we have fine particulate matter of different sizes and we have these different gases. Chemical pollution, it's really everywhere. As you can see, it's from bisphenols to pesticides, fluorides, exhaust, mercury, lead. It's a lot. It's even bigger, and that makes it very complex as well. Because, for example, and I mean, I'm also guilty of that. I sometimes still have like plastic bottles of something, of like water, of drinks, or the one that I'm really guilty about, the right one is, on a lazy night, I don't want to cook or whatever. So I buy these meals that you say like, poke some holes in it and just put it in a microwave to heat up your meal. I mean, a lot of us do this, but I try not to because this is really bad for numerous of reasons. Because there are so many compounds in this plastic film, in plastic bottles. And I think the one we all know about is microplastics. I think nothing has gained more attention in the last years than microplastics in terms of pollution. It makes sense because it is everywhere. All of us at this point, we are exposed to smaller plastics. And this study, it was really a groundbreaking study, especially in the field of cardiovascular disease because they found plastics in our blood vessels. So and they that was really crazy at that time. No one at that time was able to prove it, but they were the first ones to show that in our blood vessels, and you can see it on the images I added here from this paper, we actually can find human-made plastics in our blood vessels. And more so, they found that those individuals with a higher amount of plastics in their blood vessels, and that's in yellow, if I'm not mistaken, they have a higher risk for cardiovascular disease. And this was a very big study. It was not just a random small study. It was published in one of the most prestigious journals that we could publish in. And this was really groundbreaking. From that moment on, we kind of acknowledged the fact that, okay, plastics, it's not inert, it's really a big problem. And more so, plastics is one thing. There are many other compounds that are related to plastics. I think bisphenol A might ring a bell for you. It's BPA. Sometimes in the supermarket you find products that say they're BPA free. It's because BPA or bisphenol A is a compound that is known to really increase our risk for cardiovascular disease, shown by numerous studies. And it is also almost always it comes together with plastics. The same goes for phthalates, which is another group of chemicals that are used in the production of plastics, but are still in plastics. Also, those compounds have been found to really increase our risk for cardiovascular disease, as you can appreciate from the graph. Now, plastics is a big topic. It is a very, very big field. At least someone to try to understand what plastics do on our health, and more specifically, what can we do against it? Because we know we're all exposed. So yeah, what can we do in the future? But there is also another compound out of the millions of compounds I could be discussing right now. There is one other compound that I also want to discuss. And it's what Andreas also told in the beginning. I work on these chemicals, which are called forever chemicals. Another word for that is PFAS. So these are small chemicals that are used in various applications. It's even more widespread than plastics. And the problem is they're called forever chemicals because once they are in the environment, similarly to plastics, they will probably stay there forever. They cannot break down. So we keep on producing them for numerous applications that I will show you. We are polluting our soils, our waters, eventually ourselves with these compounds that cannot disappear. Just to give you an example, PFAS can be found in anything. It can go from clothing, because like raincoats, for example, they can really, they keep out the water. That's what we want. But the reason they keep out that water is because of these chemicals. Same goes for pizza boxes, the pans, non-stick cookware, those pans where you don't have like the anti-stick layer, that anti-stick layer is pure PFAS in most of the case. So just to show you that really there is a lot of exposure to plastics on the one hand, but PFAS that we really don't know about. There is so much. The problem is that to talk about PFAS is complex because unlike plastics, there are thousands of PFAS molecules. And to make it even more complex, that every one of those compounds is doing something differently. There have been a limited amount of studies trying to understand how PFAS is linked to cardiovascular disease, and they found the same thing, is that, well, for example, here, if you look at the table here below, for example, PFOA, it seems to be causing hypertension. That's one thing. But then on the other hand, another one, PFUNA, PFUNA, is seeming to do atherosclerosis. It's very different. There is not a clear thing that they're doing. Each and every one of these molecules is doing something very differently. And that makes it very complicated because we are creating, as a society, more and more of these molecules, but we're really lacking behind. Our research cannot follow. Since they are so inherently different, they're doing so many different things. It's taking years to just understand how one of these molecules work. Keep in mind, we're making hundreds every year. So this is a big challenge in our field, is to understand how PFAS is, what the mechanisms are of PFAS pollution and cardiovascular disease, except that we know that they do something really bad to our cardiovascular system. So the problem with this is that or what I wanted to do is like, this is my kind of research, is where I try to understand how PFAS is affecting cardiovascular health. But it is too broad to narrow it down in a small talk like this. But maybe there is an opportunity in the future that I can give like a more specialized lecture specifically on PFAS itself, because it's a very broad, complicated topic anyway. And by then, I should have also had more data myself. But to go back to it, I only covered barely one chemical, which is plastics, but there are so many more. We didn't talk about lead, we didn't talk about so many others. But one thing is for sure, and that's a statement that the European Environment Agency gave recently, is that we simply don't know. We really don't know enough. We don't know how much we're exposed to these chemicals. Since there are so many chemicals, we have no clue to which ones we really are exposed. And even if we know, we have vaguely an idea on how they're affecting our cardiovascular health. So this is something that the European Union and the European Environment Agency are working on, trying to perform research and studies to monitor how much we are exposed. And then, of course, academic institutions are working on trying to unravel the health effects of these chemicals. So I'm actually nearing the end now of this very limited lecture, but I think we can acknowledge that urbanization and the challenges that it brings, so noise pollution, light pollution, air and chemical pollution, they are very much linked to our cardiovascular health, showing that an increased amount of exposure to this pollution is tied into a higher risk for cardiovascular disease. And that the way they do it is very different. It's interesting because I think like noise, light pollution, it seems to be more stress related. It seems to be maybe that there is an involvement of our sleeping patterns or disturbance of sleeping patterns into this. Whereas if we look at air pollution and chemical pollution, it seems that these pollutants, these toxins are really attacking us straight ahead. Air pollution goes through our lungs, chemical pollution probably through our digestive systems, but they are directly causing inflammation. They are the root cause of our disease. Now, I've been speaking doom and gloom, like a lot of doom about like, we're in a bad position at this moment, but we also need to realize that pollution, for example, air pollution in many cities is decreasing. For example, even in Maastricht, where we do see a trend that over the last 8 years, our air quality is getting better. So that's something to take into account. And also, for example, with a lot of these chemical pollutions, I think the public is very aware, or at least aware, and they are, actively protesting, for example, PFAS. I think when it comes to PFAS, every now and then in the news, you find groups of people that go on the streets and want better regulation. And the EU is listening. They're really doing a lot in regulating these chemicals better and better. So that's good news. So it's not only that, oh yeah, we are in big problems. There are lots of pollutions. It's damaging our health, which to a certain degree it is. We need to understand also that at the EU level and also national levels, they're really doing the most that we can to try to limit our exposure to this. Still, it is important for us to not only regulate better, but also to understand why they're doing it, so that we can also find maybe ways to treat people or to better manage this in the future. But yeah, we're not there yet in terms of in the science. Like we are missing a lot of things. So I've been also talking about noise, light, air, and chemical pollution separately, and that's because a lot of this research is being done individually or separately. Like some researchers are doing only noise pollution, some researchers are doing air pollution. What we are seemingly forgetting is that all of these things are happening simultaneously. Like you can imagine in a city, you will have both light pollution, noise pollution, and air pollution. They're all happening, and we don't know enough on how all of these things are either, synergistic, or are they doing something differently or worse? And that's one thing. The other thing is, of course, that every city will be different. Like Maastricht compared to Amsterdam, compared to Brussels, compared to Copenhagen. These are inherently very different cities. So that will probably lead to a very different kind of exposure to different noise, light, and so on. Another thing that we don't know enough about, sure, we know that pollutants are increasing our risk for disease, but we do not really know who really are our vulnerable populations. Is it just everyone, or is it maybe those who already have asthma or another lung disease? Are they more susceptible to it? Probably. But we need to do more research on that because we don't know enough. And then it needs what I just mentioned, interventions. So it's one thing to know that we're exposed to these pollutants. Another thing is to figure out whether that exposure is increasing our risk for disease. But what we have no clue about is what can we do about it? Is there a way that we can make some treatments, or sure, we can try to avoid as much as possible, like don't poke holes in the plastic film of like a microwavable meal, We can limit our exposure, but maybe we should also be looking more at, can we do something more? Can we create some interventions or some therapies to reduce that risk? And then overall, and that's yeah, a consequence of what I just said is then the cost effectiveness of such a strategy. Because we need to take into account that if we want to start screening everyone for every of pollutants, that's going to cost a lot of money. And that's money that governments at this moment do not have. So we need to figure out like what is effective and what can we do so that it is actually cost effective to implement such a strategy. And that is, of course, still very far in the future because there are many things we first need to discover, like what can we do, like in terms of interventions and so on. But yeah, so we're not there yet. We in the last years, our research has been booming exponentially in terms of we are getting very aware of all of these pollutants. We're getting aware that they are a risk for our health. We are really already far in some fields on unraveling the mechanisms behind, like why is it? So we are in certain fields already very far. There are still very, very much questions about this. And so that's exactly the kind of research that I'm also doing at this moment, is I'm trying to understand how pollution is affecting our cardiovascular health. I'm only doing this very recently, so I can't data, which is why I couldn't at this stage, but I hope in the future that might be different. But yeah, I think the topic is interesting. It is important at this stage. The regions where we live in, we know that they are polluted. So yeah, there is much more research going on in this field. I wish that we should do everything. That's just impossible. But yeah, no, I'm gonna stop right here. I hope you learned something more about pollution, cardiovascular disease. And please, if there are any questions, I would really love to answer. Yes, thank you very much.
Well, thank you so much, Cedric, for this lecture. I learned so much from you just in these short 35 minutes or so. So thanks a lot for this and for this general overview and also taking the freedom to step away from your expertise and paint a very broad picture. I
Yeah.
know enough scientists who are very careful to step outside their own very specialized expertise, so I appreciate that.
Mm.
I would ask you to just stop sharing maybe that we can all
Yes.
see each other. And would like to go into a Q&A session with all of you guys. I personally have many questions to ask, so if nobody else is taking the floor, I'll fill the time. But to do this in a structured manner, when you go on the bottom of your Zoom bar, there's this little heart with react, and under that, when you click it, there's a raise hand button. So you could just raise your hand, and then we automatically get sorted in an order to ask questions. Maybe that's the easiest way to keep a polite order going. But for now, there are no raised hands. So whoever unmutes themselves first can shoot the first question. Katinka, thank you. Go ahead.
Happy to start with the questioning because I know many are thinking a lot. First of all, thank you for an excellent lecture. I hope that this recording could be put also in the YUFE Academy shared video lecture site. I think it would gain quite a lot of views. And I'm really sorry that you suffered a little bit from the fact that we didn't have enough time to market this lecture, but excellent lecture. Thank you for that. My question was especially related to this air pollution part, which is not in your focus as such, but I was really struck by the numbers. And is there some kind of general statistics where you can kind of clearly see that, okay, thanks to this increase in air pollution, we have this much more of this kind of illnesses on global level?
Yeah, no, thank you. That's indeed a good question. So what I gathered, the European Environment Agency, they give a lot of data out, a lot of statistics, because what I showed, I think, was globally. Yeah, we know there are many papers that also discuss that. I think I'm going to guess, but I think it was around 15 to 20% of overall global deaths are due to pollution, air pollution. They really have those numbers. The statistics are out there, especially when it comes to fine particulate matter. Yeah, we know that this is very bad, that they are really increasing mortality rates and that they are the cause of it. So there are the statistics, the environmental agency, they do publish them on their websites. But there are many papers, of course, available for this. Absolutely, yeah.
Then I'll just inject myself here. You said that a lot of these things we're not researching in a systemic way and how they all tie into each other, right? They're all researched separately from each other. And then you said we actually don't know enough yet for where to start the prevention routes best. Letting go of all the scientific, we need hard data for every decision. What is your knowledgeable intuition of what is all low-hanging fruits? Where could we really fix the low-hanging fruit on a systemic level with good bang for the buck? That I would be really interested in that.
Cool. That's a good question. Just let me think 1 minute about this.
Sure, take your time.
Yeah, the problem is this needs to come from the EU because on a national level, policies are already difficult and different between countries. This needs to, and that's exactly what the environmental agency is trying to do because they're doing great work for this. Because I think, for example, the chemicals decisions they make are good, like with the chemicals with PFAS. We only noticed for a few PFAS a few years ago that they are very harmful for us. EU said any PFAS is banned. Like they are really now working in their ways like, okay, we don't know, but it's better to not like to block it out, the restrictions, to not produce it anymore, rather than only go specifically one by one. So their strategy is good because science is slow. I mean, if we really want to study every individual chemical pollution or something else, yeah, that's impossible. Then we're probably in my lifetime, I can probably just do a few molecules and maybe I know something better about them. But so what is low-hanging fruit? I think there is quite some data out there on a lot of pollution or exposure. There are a lot of cohorts being studied in different cities. We can try to already do this synergistic effect. We have data from everything. Can already try it. It's not that big of an effort compared to other kind of research. That could help us a lot by really looking more at synergistic effects, air pollution, chemical pollution. Of course, we only know what we know. As I said, with chemicals, it's tricky. But yeah, it's a difficult one, right? Because I think only in the last couple of years, we are really into biomonitoring of people. So yeah, it's easy to say now, like, oh yeah, okay, we're missing this, but a few years ago, we didn't even know that there were plastics in us, so it's continuously evolving. It's difficult to predict where this is going. I think the best way is to just combine multiple data that we already have, look at trends, and then immediately push for policy. Don't wait too long because we know they're harmful, but that's what the EU is doing already. So that's a good strategy at this moment, I would say.
Yeah, thank you. Just something from my own environment that I noticed. Well, I like the night sky, so I'm very aware of the light pollution where you can all not see it anymore. And the street lights or on our streets were kind of they had like a higher angle and they were shining up into our first floor bedroom.
Okay.
And now, without me getting into action, the city already replaced the streetlights in our neighborhood, and now they have a shallower angle, so I don't have the streetlight in my bedroom anymore, and it's so nice. It's like I don't because now I get air through the holes in the shutters, and I don't have to blind out everything. So for me, that was like really nice. Like yeah, when they have to be replaced with the newest LEDs, you can just fix this in one step. So that
Yeah, exactly.
for me that was a really really nice step.
I can imagine.
Other people with questions, because otherwise, as I said, I have many and can just continue. So I'll just give the rest a minute to come up with something. Katinka.
I'll keep matching you to change the voice every now and then. Obviously, there is the question: what can an individual do? Kind of protection list. Should we have some kind of try to avoid these and when possible, do not go in places X kind of instructions. And if those exist already, where to find them, because sometimes the wheel has already been invented. But anyway, it would be nice to know what's out there.
Absolutely, 100% agree. I think the one thing we shouldn't do is, especially because I gave this talk to some others, is like we should not panic too much, because then if we're going to panic, I think you're going to stay inside. But I think when it comes to chemical pollution, most of them, I think it's important that we have more awareness. Like I think with plastics, like what I said, like poking holes in microwave, or like microwaving anything with plastic, to be fair, there are many things you can do to limit yourself to chemical exposure. Same with PFAS, this non-stick cookware. You can also just buy, not those things and others. So you can limit your own exposure. But I think I agree, it's difficult. I don't know in your countries how much the government is like showing, like, okay, you could limit yourself to that and that. I know in Belgium where I live, it's limited to just a few chemicals. So you're right. There should be more of a better message, like avoid. You limit your exposure by doing this and this and this. Sometimes it's unavoidable. Like for example, clothing. Everyone still needs clothing, right? I mean, there are chemicals in clothing, but that's what I mean. We should not panic too much about that. But what we can try to avoid, we can try. We should. It's like don't use plastic bottles, don't use microwave heatable plastics or whatever. But air pollution is tricky, right? Because that's something you can not really do much about in terms of outdoor pollution. Indoor pollution, different story. Because what I didn't talk about is that there's a big difference between outdoor air pollution and indoor air pollution. And most of the time, it's the indoor air pollution that's more detrimental for you than the outdoor. So, of course, a good ventilation where you live is important. Don't have like open fires or whatever. There are many things, but I agree. Maybe I haven't really found that, maybe because I wasn't looking hard enough, maybe, but like create guidelines on like what we should mention to the public. Like this is what you should do or should not do. But my fear with this is that if you're going to pull out the list, you're going to see that almost everything you have, even your couch, there's stuff in your couches, flame retardants, other chemicals. That's what I mean. It's difficult. But yeah, I think plastics is one of the things most of us are aware of, and most of us can do something about it or avoid it sometimes.
Well, I think when you as an expert say maybe you didn't look hard enough for the prevention lists, then the general public is definitely not
Exactly.
going to find them. So there is a big gap
Exactly.
to close just on the individual prevention level we can do before regulation catches up as well, right?
Yeah.
Then I'm just going to link into this also with your PFAS expertise in plastics. You said like just don't use plastic bottles and just don't use plastic food containers. If I look at myself and just what I'm thinking right now, I so far thought that using plastics were labeled with they have these triangles labels, and when there's like the 5 in the middle, then there's no softeners, no BPAs in there, and then that's like I drink all of my water from these plastic cycling bottles because they're nice and they don't break and they're not so heavy. And yeah, I reheat my lunches in just the same plastic lunchbox. It's that stuff where you're saying like even if these are labeled to be free of BPAs and everything, just don't use it at all categorically, period.
I think, yeah. So I don't know enough about plastics, but the thing is like with the BPA-free plasticware, I've seen a lot of drinking bottles that mention it's BPA-free, which is good because BPA is a big hazard, what I showed you earlier. but it's not the only compound in plastic. Huh? It's like, sure, it's BPA free, but if there are still phthalates in it or other compounds, they replace it with something else. It's a strategy that a lot of companies have been doing, is that, okay, we cannot use, let's say in this case, BPA. We're just going to create something new that does exactly the same, but it's not BPA, and then we're going to replace it. Because companies, of course, it's the same with PFAS. There are regulations on, for example, the pans, the anti-stick pans. Yeah, we can't use it anymore because it's PFAS. Okay, sure, they'll create something new. So it's a new chemical. It's the same with plastics. I think the best thing you can still use is either like metal or like glass. For me, my lunches, I bring them in glass containers, or like, okay, glass drinking bowls is a little bit more difficult, but yeah, I mean, I would try to avoid it in general, because even if it's BPA free, it's still plastic. So there is, and especially when you have food containers and you're gonna poke with like a fork or a knife in it or whatever, you're cutting loose plastic molecules. And I think there have been studies that show that if you just scratch with just a fork over some kind of plastic, you're gonna release thousands of plastic molecules anyway. So it's like, yeah, it's BPA free, that's good, but it's not everything. There are way more pollutants in there.
No, yeah, thank you so much. That yeah, eye-opening to me. No, yeah, for real. Because then I think like, oh, it's free, must be good, right? But yeah, you're right to just replace it with another thingy that we don't know about, or that is just equally a little bit less hazardous.
Exactly.
So yeah, no, I have to go into a little shopping spree, I think. So yeah, no, thanks. Um, in the Netherlands, also like a question. Sorry, anybody else? Otherwise, I really just take over here. Well, then I just continue. So in the Netherlands right now, there is a discussion. There was a PFAS, or is a PFAS production plant site, and has been there for a long time. And now there's these documentaries coming out how badly polluted the environment there is. That the groundwater below this factory can never ever touch anything else and has to stay contained there because it's so bad. The people in a radius of I don't know how far have been told to not eat homegrown vegetables and eat eggs of their home-fed chickens anymore because they're so contaminated with PFAS and all other pollutants there. Um, I mean, that's very specific to the surroundings of this factory, but I also see discussion going wider now into just don't eat eggs from your chickens in your own garden anymore. Especially because of the PFAS pollution that they absorb through worms and insects and whatnot, what they eat.
Mm.
Um, do you have an opinion on that? How to just in general, how to see this and how serious to take this next to the plant productions, but also just in general in the country.
Yeah. Okay. So indeed, it's an opinion, yeah, because I also want to frame. I'm not a toxicologist, so but indeed, it's just opinion. From what I know from literature and from my own studies. So I want to tie this into a case that we did in Antwerp. There is this massive scandal about exactly the same as in Netherlands, about this company leaching out PFAS in the environment for many years. I think there was even a movie. No, that's Dark Waters was this movie, but that's the Netherlands, no? Yeah. So
It's the same. It's a daughter company
yeah,
of that same company here in the
exactly.
Netherlands. It's not
Yeah,
DuPont anymore, but
yeah,
different name, and they've been split off. But it's the same company with the same company tactics. So yeah,
yeah,
the
exactly.
movie is on point. Yeah.
Exactly, because the problem what we know is that these the study that we did that happened in Antwerp is that they looked at different radiuses around the factory and they analyzed indeed eggs, vegetables, soil, even blood of many inhabitants of the region. And you do see, yeah, it's crazy. If you live next to one of these plants, yeah, no, then everything is your concentration is in the eggs of chickens, vegetables. It's immense. It's huge. It's ridiculous. It kind of numbs down the further you are from that plant. It's very unpredictable, I feel, because I only see one study. I don't know how this translates to others and if it gets into the water. Yeah, it's difficult. I mean, I myself, I don't have chickens, for example. So I mean, I don't know, but I would probably not. Yeah, it's hard to it's really hard to really say something about this because I don't know enough about that. I would avoid it simply because chemical plants are a big problem for sure, but it's not the only source. Because even, for example, in countries where there are no chemical plants, like for example, Netherlands has a PFAS producing plants, Belgium has PFAS producing plants, but let's take for example Austria, where there is no PFAS production, still everyone has PFAS in their blood. So it's not only the producing countries, the PFAS producers that are really exposed. It's everyone. But how that then translates to eggs of chickens. If I think that the thing is that especially if you live in a specific vicinity of such of these factories, I would just avoid it completely because from data that I see, it's like I think even in children the plasma concentrations or blood concentrations are like 5 or 10-fold higher than what it should be uh, for many reasons. It's not only the eggs but it is a big source. But how that translates to, living in Austria in the mountains and then having chickens, that's different, I imagine. But I don't know enough about that to really give a very strong opinion. But yeah.
No, but this already puts it very much into
Mhm.
perspective, and that we have the clear data for surrounding the production plants.
Yeah, yeah,
Then indeed, when you're isolated from those, it's just your general environmental pollution that you can't do anything about anyway.
yeah, yeah.
So no, thank you for that. Um, we are 1 minute before closing time. So I think I'll just round it off here. I'll plan drinks with you very soon again to ask the rest of my 150 questions. Thank you so much for this and for this very informative lecture. And I think you did a great job breaking this down into level where the non-expert can follow and learn a lot from all of this. So thank you so much.
You're
Thank you for
welcome.
everyone for attending. And then yeah, I'm looking forward to the lecture once you have your own data in where we can learn all the specifics about the effects on the PFAS that you've learned on our cardiovascular health.
Yeah.
So yeah, thank you everyone. I wish you a nice day and see you around in the next Youth Academy lectures.
Thank you, everyone.
Thank you. Bye.
Bye bye.